between the sizes of the triangles when they had 45, 45, and 90 degrees, which is an isosceles, right? So they said, well, if there's a triangle that has two sides that are exactly equal and it's a right triangle, then this is a relationship that they have. So instead of using the Pythagorean theorem for all triangles, we can use this one shortcut. So today we're going to be using special right triangles to find missing side lengths of 45, 45, 90 degree triangles. So we don't need our computers right now. Those of you here, you don't have to close them all the way, just close them half. Yes, but we're going to do the notes right now so you guys can understand. But don't close it all the way because we need the Pear Deck when we practice. But take a notebook out because you will need it. Or some paper. I have some paper up there, some pencils. Worst case scenario, if you don't remember this, you can always use Pythagorean theorem, but we want to work smarter, not harder, right? Okay, let's go ahead and start this off. This is my first type of special right triangles. The degree measures are 45, 45, 90. So when you hear somebody say it's a 45, 45, 90, that's what they're talking about. And those angles create isosceles right triangles. And isosceles means that we have two sides and angles congruent. Or that are the same. Well, let's put the same. And then the right tells us we have a 90-degree angle. So we're going to sketch this triangle. And we're going to put two sides congruent. And remember, if two sides are congruent, that means that this angle is 45 degrees and this angle is 45 degrees. Questions so far? Eva?
Can you go back to the notes? I accidentally missed it.
To these notes or to the ones from last week?
Yeah, just those. Like, yeah,
This
I just
part?
want to.
Eva, do you?
Thank you.
All right. So if we had an isosceles, we know that this side is X. What would be the side length for this one? X also. Now, if you recall from last week on your assignment, we'd have X, and then the hypotenuse is the square root of 2 times larger. What happened? Okay, so what is this telling me? Because I'm
Ellie calls her to show a student.
You're showing a student you're late because of this?
Yeah, I have to go get this.
Okay, and then?
She told me to show you this.
So you're not going to be here?
I'm going to be here as you call her.
Or you said?
I'll leave class like 3 minutes ago.
3? Okay, sounds good. So the hypotenuse is always going to be the square root of 2 times bigger. So notice how this hypotenuse is going to be across the 90-degree angle, and notice how the hypotenuse does not touch that 90-degree angle. So be very conscious about that. My hypotenuse is always across the 90-degree angle, and it is never going to touch that 90-degree angle. So we're going to put 45. This is a little table that could help you. 45, 90. So the angle, or I'm sorry, the side that's across the 90-degree angle is the x times square root of 2. The side that's across this 90-degree angle, I'm sorry, 45-degree angle is x. And then the side across this 45-degree angle is also x. Okay, we're going to start with one example. But before we do that, we can have 2 little notes. If we are missing the hypotenuse, then all we have to do is multiply the side length by the square root of 2. Which means whatever my side is, we're going to multiply it times the square root of 2. And we're going to do one example here. Here you go, sweetheart. You might want to take your stuff. I don't know if, and then if you can come back, then just bring your stuff back with you, okay? All right, so if we have an isosceles right triangle, and let's just say we have this side length is 3, what do we know about the other side length? 3. And what do we know about my hypotenuse? If we're missing our hypotenuse, what do we have to do to the side length? Multiply it by what? By the square root of 2. So we're going to get 3, multiply it by the square root of 2, and then simplify. What's 3 times the square root of 2? 3 square root of 2, right? Yeah, that's it. 3 square root of 2. Now we can go on. Yes. I'm sorry? I'm sorry? Put your mask on, please. That's okay. We'll fix it right now. Let's look at the notes, please. So let's say we use the Pythagorean theorem. Let's say it's 3 squared plus 3 squared is equal to c squared. You do not have to write this part down. I'm just showing you how much time and effort you can save by knowing the relationship of special right triangles. This is 9 plus 9 is equal to c squared. We get 18 equal to c squared. We do the square root. We know we have to simplify. The largest perfect square is 9 that is divisible by 18. It's 9 times 2. This is 3, square root of 2. Do you guys see how you have the same answer? But if you look at the relationship, if we know that both sides are equal and it's a 90-degree angle, then we can say that the hypotenuse is it's the square root of 2 times bigger than each side. And then what's the opposite of multiplying by the square root of 2? Dividing. So that makes sense, right? If we are missing one of the leg, missing a side length, then we need to divide the hypotenuse by the square root of 2. So that means that we have our hypotenuse, and we're going to divide that by the square root of 2. And let's go ahead and do an example for that. By the square root of 2. Now, what's the square root of 2 divided by the square root of 2? 1, right? Anything divided by itself is 1. So what's left over? 5. So x is 5 and y is 5 because they're both congruent. Any questions so far? All right, go ahead and go to the Pear Deck. Know that this angle over here is 45 degrees. And if they're both 45, that means that these two sides are congruent. So what do we know about n? What is n equal to? If you look at the tick marks, look at where the tick marks are. What is n equal to? It's equal to 8. These tick marks mean that they're exactly the same. Any questions on n? Now, if we go up here, we're missing our hypotenuse. So if we're missing our hypotenuse, then we need to multiply the side length by the square root of 2. So my side length is 8, and the hypotenuse is square root of 2 times bigger. So we do 8 times square root of 2, and we get 8 square root of 2. So m is equal to 8 times the square root of 2. And if they give you the hypotenuse, you would just go the opposite direction. Go ahead and try the next one. And a question mark is not an answer. I'm not saying it was you. Please try and give me answers that you think they are, because that's how I know whether or not you need help. If you guys notice over here, the two sides that are equal have a number, right? And notice the only thing that's different from those two sides. So if you work backwards, it's the same thing. Where you know we're multiplying each side by the square root of 2. So if we remove that square root of 2 from the hypotenuse, what's left over for the two sides? $11. So if you have 11 square root of 2, this is the math part of that. We want to divide it by the square root of 2. Because they're giving